Okay, tissue rejection. It is another example of when your immune response doing its job, but it causes undesirable effect. So organ transplant is a good thing because it helps to save people's life. But the issue is that after a patient receives an organ transplant, the patient's immune system will recognize the transplanted organ as a foreign because they have a different MHC protein. So the immune system will start to attack the cell or the organ that expresses a different MHC protein. And it is difficult to find so-called matching of the organs. So what happens is that we have to use immunosuppressive drug. When we suppress the immune system of the patient, it will make the rejection, tissue rejection, less severe. But of course, when the patient takes an immunosuppressive drug, it will also lower the so-called immunity of the patient, so that the patient will also get sick easier. And this is one drawback. And the second drawback is that the immunosuppressive drug is not 100% guarantee that works, because the transplanted organ may still be under attack. So if the attack is severe, it can actually damage the organ. So it is not 100% efficient as well. It has the side effect causing the patient to easily get infection, and also it's not guaranteed that the transplanted organ will not be damaged. So scientists developed something called xenotransplantation, meaning that they use animal organs instead of human organs. What happened is that we use genetic engineering to make pigs less antigenic by removing the pig's MHC antigen. Because it is in the pig tissue, it is in the pig, then it will be, we can call it more humane than working with a human tissue, okay? So the goal is to make pig organ as widely accepted as type O blood. Remember, type O blood is a universal donor. So the goal is to make pig organs to be available to all human use. But as I told you before, genetic engineering, the success nowadays is not that high still. It's more like a experimental phase, yeah. Okay, other autoimmune diseases. So it is like, because of cytotoxic T cell or antibodies that we make, they, for example, cytotoxic T cell, they may have an antigen receptor that binds to our MHC1 protein. So in this case, when this happens, they will attack our own body tissues. Depending on what type of body tissue that they attack, we have different autoimmune diseases. For example, myasthenia gravis. Myasthenia gravis, the symptom is muscle weakness. The reason is that our immune system attacks the neuromuscular junction, specifically the acetylcholine receptor, the nicotinic acetylcholine receptor. And then multiple sclerosis, it will also cause, it is also a neuromuscular disorder because the immune system attacks the myelin sheath on the nerve fibers. Myelin sheath, we will talk about myelin sheath in the nervous system. And then we have systemic lupus erythematosus. This is the kidney damage. Your immune system attack your kidneys. And last but not least, the famous rheumatoid arthritis. Your immune system attack the cartilage in your joint. And of course, we can also have immunodeficiency disease. One is acquired, that is AIDS. We all, hopefully most of people know, the HIV, human immunodeficient virus. This virus, HIV, they target the T cells, so that if the patient has a T cell count very low, then a doctor will diagnose it as having a full-blown AIDS. So the T cell level, as you remember what we learned today, T cell is for telling other cell to start to mobilize, to start to secreting antibody, or to use for the cytotoxic T cell to tell the cytotoxic T cell which cell to attack. Because helper T cell, they secrete cytokine like interleukin-2 to tell other immune cell to mobilize to attack. If cytotoxic T cell is all dead, if helper T cell they are dead, or you have very low helper T cell count, what will happen? B cell, cytotoxic T cell, or natural killer cell, none of them will be mobilized. They will not know that, we have to attack the invader. That's why AIDS patients, they do not kill by HIV per se. They're killed by other infection. Because when other infectious agent go into their body, their immune system cannot alert, and then there will be no immune response there, and then they are killed by flu, simple diseases like flu or cold. And then we have the primary or congenital immunodeficient, meaning that people are born with this immune deficiency. Because they inherit a missing or impaired immune system. One of them is called severe combined immunodeficiency syndrome. What happens is that the antibody and cell-mediated immunity, they don't have it, or it's not inadequate. An example is the famous one called Bubble Boy. A kid, he was born with this congenital immunodeficiency, so he has no immunity to anything. He was born like this, so people put him in a balloon or bubble, so that he was isolated from the surrounding, so that he won't get any infection. Okay, that's the end of this week's online lecture.